Ise-Shima. Home to a rich sea that has sustained communities since ancient times. Here in Funakoshi Hammer, the tradition of amadiver fishing still continues. These blessings have long been sustained by sea forests, seaweed beds expanding along the coast. These cradles of the sea facilitate the spawning and growth of fish and shellfish. Today, however, Japan's coastal areas are facing a crisis called sea desertification. It is a phenomenon where seaweed that once covered the seaweed beds disappears, exposing bare rock and leaving the seafloor barren and whitish. In seas that have lost their seaweed, marine life disappears and the ecosystem itself is beginning to change. Here in Ise-Shima, the seafood that once filled these waters has disappeared, and now the traditional livelihood of the amadivers is quietly fading away. To restore the lost seaweed beds, Nippon Steel has started nurturing sea forests. Sea desertification is believed to progress when seaweed growth is inhibited by multiple overlapping environmental changes. These changes include a depletion of iron, a nutrient for seaweed that is naturally carried from rivers to the ocean, due to coastal construction and dams, as well as rising seawater temperatures. If the decline of seaweed beds continues, the role of blue carbon, the process by which seaweed and other marine organisms fix carbon in the ocean, which has gained attention in recent years, will weaken. This trend is raising concerns about impacts on global climate change and ecosystems. This is Sea Laboratory, a marine environment simulator. It recreates a coastal marine environment indoors, where research is being conducted on how the marine ecosystem works and how seaweed absorbs carbon dioxide. Nippon Steel has developed the Vivery unit, which uses steel slag, a byproduct of the steel-making process, to provide nutrients to the sea. Steel slag contains iron, which seaweed needs to grow. To make that iron slowly dissolve into the seawater, we mix the slag with humic substances made from thin timber. We call that mixture a Vivery unit. By combining steel slag with humus, the system allows dissolved iron to gradually spread into the sea. This initiative to restore seaweed beds began in 2004 in the waters of Mashike, Hokkaido. Through collaboration with local fishing cooperatives, Vivery units have been installed in various coastal areas, leading to regenerated seaweed. Using Vivery units, we are advancing the UMIMORI Project nationwide, a demonstration initiative to restore seaweed beds. The project has expanded to Tomari Village, Hokkaido, and Onagawa Town in Mie Prefecture, and now to Ise-Shima. Ise-Shima was once called Umashikuni, bountiful land, and boasted a fertile sea blessed with abundant marine delicacies such as abalone and turban shells. Ama fishing was thriving, with many amadivers freediving for their catch. However, due to sea desertification in recent years, the region is now losing these traces of its glory. We dive into the sea and gather our catch, turban shells and all kinds of things. In the old days, we used to bring in dozens of kilos, but now it's really only 2, 3, maybe 4 kilos. That's about all we get. In Funakoshi Hammer, abalone catches have declined to 1/30th of what they were 30 years ago. My name is Masaru Terada, and I serve as the head of the Fishery Rights Management Committee for the Funakoshi district. I'm still working as an active amadiver. For the past 3 years, I haven't been able to catch even a single abalone. It's definitely because the seaweed has disappeared. Seaweed is what abalone feed on. Without kajime or arame, they simply can't survive. In 2023, Nippon Steel partnered with the Mie Offshore Area Fisheries Cooperative Association, Funakoshi District Fishery Rights Management Committee, to begin the ambitious initiative of restoring Ise-Shima's abundant sea. First, the beach is excavated and bags filled with vivary units are buried. They serve as fertilizer for the sea. Iron seeping from the buried bag spreads offshore, carried by the waves. Additionally, vivary rocks, artificial stones using steel slag, are submerged in the sea to serve as habitats for seaweed and small marine organisms. This project has been supported by divers from Funakoshi. Pretty much all of the divers are helping with this. We even take our boats out to support the work. I help with planting the seaweed and other tasks. We joined in because we'd be really happy to see the seaweed grow back and the sea improve. 2 years since the installation, approximately 3,400 seaweed plants have begun growing in the surrounding area. This year we're already seeing remarkable results, and when I actually saw it myself, I was really surprised. Spores released by the mature seaweed are expected to spread and create core seaweed beds that will serve as starting points for further expansion. If the recovery of seaweed beds continues smoothly, we plan to further increase these core seaweed beds. I hope we'll see even more progress and that this place can become a kind of model area, encouraging other regions to take on similar efforts. My dream is that while I'm still working as a diver, the seaweed beds will recover and the abalone and turban shells will increase again. Our dream is to restore these waters to a fertile sea once again. We have just taken the first small step. But now, the power of steel is beginning to cultivate forests in the sea. Cultivating sea forests through the power of steel.